Welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 3, Lesson 10, More Work on Proportional Relationships. All right, thankfully, our last lesson in Unit 3, which has been all about ratios and what happens when ratios are constant for two variables, i.e. proportional relationships. We've worked with graphs of proportional relationships, the algebra, the equations, all of it. This last lesson, we're just going to kind of summarize it all, work with those concepts yet once again. Some of the mathematics in this lesson will get a little messy, so I'm going to have my calculator kind of out and ready to go. I would suggest you do the same. Let's jump right into it in exercise number 1. Here we go. Exercise number 1. Matthias is conducting a science experiment where he grows a corn plant. He finds that the height of the plant, h, in inches, is proportional to the amount of time, t, it has been growing, measured in weeks. After 6 weeks, the corn plant is 15 inches tall. Letter A asks us to find the ratio of height to time using the point given, write first as a fraction, then express your final answer as a unit rate with appropriate units. All right. We've done this again and again. So take that piece of information that says that after 6 weeks the plant is 15 inches tall and produce that unit rate in letter A. All right, easy enough, right? We want the height to the time. We want 15 inches divided by 6 weeks. Here we go. So 15 inches divided by 6 weeks. All right, let's use our calculator really quick just to do the division. 15 divided by 6. That's going to give us 2.5. We want proper units. So 2.5 inches per week. All right, the follow-up question, what do we call that number? Pause the video now and write down what the technical name of that number is. All right, hopefully you said the constant of proportionality. It's a big piece of terminology, but it's pretty important. That's the constant of proportionality. Wow, that's a long word. It's so long that our magic red pen showed up. Here, we'll just copy over it in blue. Right, it's the constant of proportionality. So whenever we've got proportional variables, and we definitely know these are proportional just by looking at the graph, right? Goes through the origin and a nice straight line. The constant of proportionality is what we call that simplified unit rate when we divide the numerator by the denominator. Now, letter B, let's take a look at that. Your answer to A corresponds to which t, h point on the grid below, state its coordinates, and plot. So we talked about this a few lessons ago. The unit rate, or the constant of proportionality, can always be seen and read off of the graph. What point shows us that constant of proportionality? Write it down and then try to plot it as best you can on that graph. All right, the unit rate, or the constant of proportionality, can always be found at 1 comma this number. So in other words, we should be able to see that. That just was really strange. We should, let me rewrite that little f. We should be able to see that at the point 1 comma 2.5. And in fact, we can see that. It's kind of good that we have got the graph. Here's 1, and if we go up to the graph and come over, it's pretty obvious that that's 2.5. All right, the unit rate slash constant of proportionality can always be seen at 1 comma whatever the y coordinate is. And that y coordinate then is that constant or the unit rate. Now letter C. Fill in the blanks below. H divided by t is equal to what? And therefore h is equal to what times t? All right. Well, this is the whole point of the constant of proportionality, right? The whole point is, if these two variables are proportional, then h divided by t will be the same always. And what we got that one time when we did h divided by t is 2.5, and therefore h is 2.5 times t. Maybe even write it off here to the side, right? Because if we had an algebraic formula, this is the way it would look. H equals 2.5 times t. So now, if you give me the time in weeks, I can use this formula to figure out the height of the plant in terms of, I think it was inches, right? Yep, 2.5 inches per week. So let's take a look at letter D and letter E and try to use that equation sum. Letter D asks us the following. After 20 weeks, does your equation predict the corn plant will be shorter or taller than 4 feet? Justify. All right, awesome. So what I'd like you to do is pause the video now, use this formula to figure out after 20 weeks whether or not our equation predicts the corn plant to be taller or shorter than 4 feet. Take a few moments to figure this out. Now we have to be careful, right? We have to know what our time is measured in. And it certainly is the case right now that time t is measured in weeks. And that's important because if the time had been measured in days, then maybe we would have to convert the weeks into days by multiplying by 7. Here we don't have to do that. Here all we have to do is literally take t, make it 20, and then use that formula that says that the height of the plant will always be 2.5 times the number of weeks, which is 20. All right, if I use my calculator to do that really quick, I can say 2.5 times 20, and that should give me 50. And it does. All right, so 50 inches. Now the only question is 50 inches taller or shorter than 4 feet? Well, that does involve a little bit of unit conversion, right? Because 50 inches compared to 4 feet. Well, one thing I could do is I could take 4 feet and I could multiply it by a ratio, which is 12 inches per 1 foot. Notice how conveniently those cancel, and that gives me 48 inches. So, since 50 inches is taller than 48 inches, the answer ultimately to this problem is taller. Right? I mean, that's what it asked. Is it taller or shorter than 4 feet? And our equation is predicting taller because it's predicting 50 inches and 4 feet is only 48 inches. All right, last part of this problem, letter E. Using your model from C, set up and solve an equation to find out how many weeks it will take for the corn plant to reach 30 inches tall. All right, pause the video now and see if you can use this equation to figure out how many weeks it takes for the corn plant to become 30 inches tall. Well, one thing I know for certain, it's going to be less than 20 weeks, because at 20 weeks it's 50 inches tall. Now, in this case, they gave me the value of h, but they want the value of t. So what I'm going to do is I'm going to take my 30 inches, and I'm going to substitute it in for my value of h. So I'm going to get 30 equals 2.5 times t. Here now I can solve this very simple equation by dividing both sides by 2.5, right? And again, in an earlier grade we might have done the decimal division longhand. Here I'm just going to do 30 divided by 2.5, and I'm going to get 12 weeks. All right, simple enough. Let's get that calculator out of the way so you can see the entire board, and there we have it, right? Reviewing basically everything that we saw that was important with proportional relationships. From the graphs, right, that lie in a straight line and go through the origin, to the fact that we can calculate a unit rate, right, which is also a constant of proportionality, and we can see it on the graph, and to how we come up with the equation that relates the two variables and what we can do with such an equation. Let's see a little bit more of this in the next exercise, right? Proportional relationship facts. Let's summarize it all. If the variables x and y are proportionally related, then y is always just some constant times x, where that constant is called the constant of proportionality. It always appears on the graph at the point 1, k. The constant always has units of units of y per 1 unit of x, all right? So whatever the number is for the constant, like in the last case it was 2.5, right? 2.5 what? Well, the units of the y were inches, so it was 2.5 inches per 1 unit of whatever the x was. The x was weeks, so 2.5 inches per week. Now let's take a look at exercise number 2, where we actually start off with the equation itself. So let's do it. Exercise number 2. An ice cream store sells ice cream by the bulk where the total cost is proportional to the number of pints of ice cream bought. The cost C can be calculated based on the pints P using the equation C equals 0.75 times P. Letter A asks, what is the constant of proportionality? Give proper units along with your numerical answer. All right, this is simple. In the last exercise, we had to pull off a point from the graph and do some division and whatnot. Here, we should be able to just write down the answer. The thing that might be a little bit harder is thinking about the units. Pause the video now and see if you can answer letter A. All right, well, in all proportional relationships, we always have a variable equals to a number times another variable. And that number is the constant of proportionality. So the constant of proportionality in this case is that 0.75. Now I also want proper units, but that's easy enough because it's always this unit, the unit of the y-axis, which in this case is dollars, per unit of the x-axis, which is pints. So $0.7 per pint. It's simple enough, right? Every pint you buy, you're going to pay 75 cents for. A nice interpretation of that. Now, letter B asks us, what point must lie on this graph based on your answer to A? Plot it. All right, so we talked about how you can see the constant of proportionality on the graph as a given point. What point should it correspond to? Write that down and then plot the point on the graph paper. All right, well, it's very simple, right? It corresponds to 1, 0.75. Now, this is a little bit tricky, but let's talk about how the y-axis here is scaled. I mean, obviously you can see the dollars, 1, 2, 3, 4, 5. But notice how in between the dollars, it's broken up into quarters, right? So really, right, quarter of a whole is 0.25, right? We should know that. So what we really have is 0.25, 0.50, 0.75, 1. 1.25, 1.50, 1.75, 2. 2.25, 2.50, 2.75, 3. I won't keep going, right? The idea, though, is that we should now be able to plot 1, 0.75 as this point right here. I'll get rid of that arrow in a little bit, but there it is, 1, 0.75. Now, let's take a look at letter C. Letter C says, use the equation to fill in the table below for the cost of a particular number of pints. Graph the data. All right, this is a piece of cake, especially if you've got your calculator. Now, I don't think we need our calculator for the first one. If I buy 0 pints, my cost should be 0. That's very, very easy. And keep in mind, right, that corresponds to that origin point that we know all proportional relationships should go through. Now, side note, we don't have to rely on common sense, although relying on common sense isn't a bad thing. If I literally put 0 into this equation and I did 0.75 times 0, I should know the answer is 0, calculator or not. If I take any number and I multiply by 0, the result is 0. That's why 0, 0 is always on these graphs. Now, as I keep on going, I should also not need my calculator to do the second part. 1 pint costs 75 cents. That's kind of the whole point of the previous exercise. 1 is 0.75. All right, and we've also plotted that point right away, so I don't really have to worry about it from then on. For the rest of these, you can use your calculator. You could also do it non-calculator. Like, let's take a look at 2 pints, right? And we should get an answer that's not surprising, right? The equation says to take 0.75, right, the cost of 1 pint, and multiply it by how many pints we have. So for 2 pints, the cost is going to be $1.50. And I bet most of you could pretty much work that out in your head, right? If you know that pint costs 75 cents, then 75 cents plus 75 cents gives us $1.50, right? 3 pints we can do as well, which would just give us 0.75 times 3, and we end up getting $2.25. One way, of course, to keep filling this thing in is just continually adding another 75 cents to what we had before, because we're just adding on another pint, which should add on another 75 cents. Anyway, pause the video now, use the calculator to fill out the rest of these values, and then we'll plot them on the graph together. Take a little bit of time now. Now, you can use your calculator, but I would also encourage you to use some proportional reasoning whenever you can. For example, 4 pints should cost twice as much as 2 pints. Since 2 pints costs $1.50, 4 pints is going to cost $3. Now, 5 pints, you might want to end up and use your calculator to do it, but that's going to end up being $3.75. 6 pints should be twice as much as 3 pints. Since 3 pints is $2.25, 6 pints is going to be $4.50. Again, 7 pints is a little bit obnoxious. We could use our calculator to find that it's $5.25. 8 pints might be the easiest one on here because the cost of 8 pints should be twice as much as 4 pints. 4 pints cost $3. 8 pints must cost $6. 9 pints will cost $6.75, and 10 pints will cost, let's see, $7.50. That should be easy enough. All right. Now we want to graph all this data, and there's a bunch of data to graph. Now, one thing is certainly true. All this data should lie on a straight line. So as I start to kind of graph it, let me move these two out of the way so we can see our table and graph at the same time. We've got the 1, 0.75. 2, 150 is right here. 3 and 225 right here. 4 and 3, that's probably the easiest one, right? Then we've got 5 and 375. 6 and 450. 7 and 525. 8 and $6, 9 and $6.75. I'm out of room. Scroll up a little bit. 9 and $6.75, and 10 and $7.50. I should really use a straight edge for this, but I'm going to just kind of freehand it, and we can see that, as always, that proportional relationship goes through the origin and travels along a nice straight line. All right, let's look at the last parts of this problem. Maybe move my calculator a little bit out of the way. Scroll down, letter D. Barry is buying ice cream and has $20 to spend. If he must buy the ice cream in whole pints, what is the maximum number he can buy? Set up and solve an equation to find your answer. All right, take a little bit of time and figure out how many total pints Barry can buy. All right, well, what I know, let me just kind of get this down, is I know the cost is 0.75 times the number of pints. Let me just kind of write that down. Cost equals 0.75 times the number of pints. Now we know that what Barry has is $20. So ideally what we want to do is we want to solve this problem, right? 20 equals 0.75 times P. I can now solve the problem by dividing both sides by that constant of proportionality, 0.75. That'll cancel. I'll use my calculator here to do 20 divided by 0.75. I really wouldn't want to do that by hand. It'd get very, very ugly very quick. And in fact, what I end up getting, right, is I get the number of pints is equal to 26.6 repeated, right? Now, it would be tempting to then say, well, since it's 26.6 repeated, that should round up to 27. Except clearly, Barry doesn't have enough money for 27, right? The plain fact is, if I actually did 27 times 0.75, right, that would be more money than what Barry has. Barry would need $20.25. He doesn't have that. He's just got a 20 in his wallet. That's it, right? So the most he can buy is 26 pints. And he'll have a little bit of money left over. But since he must buy in whole pint increments, 26 is the best he can do. All right, let's summarize a little bit. Here we go. Right? So that was it in terms of proportional relationships, and we've seen it all again and again. Two variables that are proportionally related will have graphs that go through the origin and fall in a straight line, right? We can find the unit rate, also known as the constant of proportionality, between the two variables by simply taking a pair of values other than 0, 0 and doing a division. Whichever one's on the y-axis should be divided by the one on the x-axis. That'll give us also the proper units. Finally, we can also have equations of proportional relationships, which is simply one variable equals the constant of proportionality times the other variable. All right, we're going to be using a lot of these ideas in the next unit when we start to work with percent problems. Ooh, everybody's favorite, percent. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.